I'm ready now. Jesse, you said you wanted to look at number 15, you say?
Yeah.
Okay. So this says, oops, I'm in the wrong section here. Okay. So it says to use your find the value in the given interval using the graphing feature of your calculator. Round your answer to the nearest hundredth. Okay. So, just as a little reminder here, tangent inverse, its range is negative. So I know tangent inverse is going to give me an answer inside of one of these quadrant 1 or quadrant 4. You okay with that, Jesse?
Yeah.
Okay. So I know that just because the range for tangent inverse is that. The answer I'm looking for is here between pi over 2 and 3 pi over 2. That's quadrant 3. Are you good with how I figured that out?
Yeah.
Does anybody else want to ask a question about how I figured that out before we move forward? Okay, fair enough. So I know immediately that tangent is positive in quadrant 1 but not in quadrant 4. So the answer that the calculator is going to give me is this value here. The answer I'm looking for, though, is going to be here. And I know because of the way we define these angles of rotation that that angle is also going to be theta. Now the actual angle that I want to report is this one. I'll call that one phi. And the relationship between that angle and theta is if I go from here to here, that's pi, and then I go that much more is theta. Okay with that? Okay. So now it's time to go to my calculator. Since I know that tan inverse of 1.3 is the same thing as theta, that's what I'm going to type into my calculator, just making sure that my mode is in radians and not degrees. So I'll do pi plus tan inverse of 1.3. And that'll give me about 4.06. I think it said round to the 100th. And just to check that, I know pi is 3.14. If I type this into my calculator, I get, let's see, 4.71-ish. So we're definitely good. We're inside the interval we're supposed to be. Does that feel okay there?
Yeah.
Question about this or something else? Okay.
So on my test, is it okay if I did it on my calculator and then took a window to like pi and then like 3 pi over 2? And then what I did is I graphed like tangent of x, like a straight function, and then I just like that's still got the same thing.
Yeah, so let me just show to everybody else what you did here. So what Dan did is he said, okay, I'm going to graph tangent of x, and I'm going to graph 1.3. And I'm going to fix my window to go from the beginning of this interval, so pi, to the end of this interval 3 pi over 2. and I'm going to fix my y's just to make sure that I can see that. I probably don't need all the way to -10 and +10, but you might have used that anyways. And then if we hit graph, so this is our tangent function coming in here. This is our line 1.3. So the value that we're looking for is here at the intersection. So if you do second and trace and pick the intersect command and follow the prompts, you'll spit out the value, and it's about 4.06, same number that we got before. It's a perfectly reasonable way of doing it, Dan. Okay. Leo. Sure. Any other follow-ups on 15 before we move forward? Okay, sounds good. So 16 is the same directions, but we're given a different trig function and a different input. So the first problem that we run into is that there's no cosecant inverse on our calculator, right? So that's the first thing that I would straighten out. Let me just pick the red. So I remember that theta equals cosecant inverse of -1.5 is equivalent to cosecant of theta equals -1.5, just using our definition of inverses. And I remember sine and cosecant are reciprocals, so I can say 1 over sine theta is equal to 1 over -1.5. Everybody's okay with that? Oh, sorry. 1 over sine is equal to -1.5. And then if I take the reciprocal of both sides, I can say that sine theta is equal to 1 over -1.5, which I can translate now back into an inverse like that. If you need to turn the lights out, you're welcome to do that. I know that when it's really bright out, it's sometimes hard to see the board. So if you're having trouble seeing, you can certainly just stand up and turn the lights out. You don't have to ask me. You don't have to say anything. You can just get up and do it. You're welcome to at any point. It's important that you can see if you can't see well. Okay, before we move forward, any questions about how I did this? Questions about why I needed to do this? Okay, what's the shortcut? Is that I used the reciprocal function here and took the reciprocal of the inside, right? Do you have to show all that other stuff along the way that I did? No. I did that so you can so I could justify why I changed it to sine inverse and flipped the inside part. I don't want it to seem like magic. So I wanted to show some work as to how I did that. But that's really the shortcut. So between the inverse and or the inverse of these reciprocal functions, you can just flip the inside and switch to the reciprocal function. It's fine. Okay. So now we're going to continue on this problem just like before. So I remember that sine x, or sine inverse of x, its range is quadrants 1 and 4. And the answer that we're looking for, we're told, has to be in either quadrant 2, or I'm sorry, in quadrant 2. That doesn't make any sense. That's because I'm looking at it wrong. It's quadrant 2 or 3. Goodness gracious. Okay. Sorry about that. Pi over 2 is 90 degrees and 3 pi over 2 is 270. So it's both quadrants 2 and 3. Lee, are you still okay?
Yeah.
Okay. So if I go back to sine inverse, I know that sine is negative in between quadrants 1 and 4. It's only negative in quadrant 4. Okay with that?
Yeah.
Okay. So when I type this into my calculator, the angle that I'm going to get is this theta. Okay with that? I need to translate that into an answer in quadrant 2 or 3. Well, I know that sine is negative also in quadrant 3. Okay with that? Okay. So what I know is that this angle here has the same size as that theta. But the answer I'm looking for is this angle here. I'll call that phi. And the relationship there is pi plus the absolute value of theta. Now, why did I have to worry about the absolute value of theta on this one and I didn't have to on the other one? Because the theta in this case was a negative angle. Lee, are you okay with what I did there?
Yeah.
Okay. So now I just need to type this into my calculator. So I'm going to do pi. And then instead of doing the absolute plus the absolute value, I'm just going to do minus since I know that the sine inverse in this case is a negative number. So that gives me 3.87. Which again, this is 1.57 up here. And this was like, what was this? This is like 4.71 down here. This is about 3.14, so it's a little bit past pi. So it certainly appears to be the correct answer. Does that help?
Yeah. So how do you do that on the calculator?
Sure. So if we want to do this on the calculator, we're going to type in 1 over sine x, because we're doing the graph of cosecant, is equal to negative 1.5. Okay with that? And then I'll go reset my window. So the x's in my window are going to be the interval given in the problem. So I'll do pi over 2. And then 3 pi over 2, which is what it was already. And the y's that I have there are going to be fine because negative 3 and positive 3 are both relatively bigger than 1.5. So I'll hit graph. So there's my cosecant function. There's negative 1.5. So the intersection right here is what I'm looking for. So I can do second trace, pick the intersect command. Got to make sure that we're on this arm because there's like an asymptote right here. So I have to be a little bit careful and make sure that I'm on that part. So there I can see my cursor that I am on that arm. So I'll press enter, enter on the straight line, enter for the guess, and it spits out that 387. Does that feel okay? Okay. Other homework questions? Okie dokie. So, for the rest of our time here, I put a bunch of worksheets into the Content library. At this point, you guys should be able to do worksheets 1, worksheet 2, not worksheet 3, and worksheet 4. So 1, 2, and 4. And those will be part of the homework check on Sunday. I'm going to give you the entire rest of our time here today to work. If you have questions on anything, feel free to come up and talk to me. I'd be happy to help. Yeah, sound good? Okay, rock on, my dudes.